Okay, your three 25-minute ones that were part of this FRQ 5. I think I cited in my other video, but I'll go ahead and say so again, that these were created by a gentleman who has long been part of the AP community. He shared these with teachers to be used in their, or with their students, and so I've done so. He has, like I said, has taught this for years, has graded the AP test, and so he created these for his class. He made his out of a rubric of 15, and so we will follow his rubric here as we walk through this. So we have a particle is moving along the x-axis with a velocity function of that. The position of the particle is given by x of t. It is known that x of 0 equals 7, and so again, as I've said many times, I always jot down my desired position formula really quick as soon as I see a given point like that, just in case. Okay, part A. On the interval 0 to 4, when the particle, or when is the particle moving to the right, give a reason for your answer. So this year you're going to want to be careful. These problems are constructed so that you don't actually have to use a calculator. You are permitted to do so for this year's AP test on both of your FRQs. However, you still need to show all of your work. You still need to be able to accurately express why your answer is the way it is without a calculator, or as though without a calculator, because they aren't required, right? So you want to make sure you are not just jotting answers down and not still showing work to support why your answer is the way it is. Okay? So yeah, careful with overusing your calculator. Here we go. On the interval 0 to 4, when is the particle moving right? So particle moves right when the velocity is positive. So this comes out of our particle motion packet. We're going to go ahead and set our velocity here equal to 0 so that I can figure out where I'm positive. Okay, this one factors to 3t minus 2 times t minus 2, which gives me two zeros, one at 2/3 and one at 2. And that could be confirmed. If you were looking at your velocity graph in your calculator, you'd see that you had two zeros at 2/3 and 2. And so then we could test those intervals. And again, feel free to use your calculator to aid you in this, right? But I'll go ahead and do it without a calculator on my number line test. So plugging in, say, 0 here to my velocity, I would get a positive number. When I plug, say, 1 in, I get a negative number. And when I plug in, say, 3, I get a positive number. And so in this case, my particle is moving right from 0, which is the start of my interval, to 2/3, and then again from 2 the rest of the way to 4. Okay. And then give a reason for your answer, because V of t is positive on those intervals. Okay. Okay, when this gentleman made his rubric, he made this out of 2. Potentially speaking, I could also see this one being out of 3. I've seen years where they say something like 1 point for considering the velocity equals 0. Like I said, he made this one out of 2. 1 for identifying your zeros, and 1 for your answer with reason. You did have to have that reason there. It says give a reason for your answer. Right? Okay, part B says on the interval 0 to 4, when is the particle moving to the left? Well, the particle is moving to the left from 2/3 to 2, and give a reason for your answer, because velocity is negative on that interval, 2/3 to 2. Okay, he also made this one 2 points, 1 for the answer, 1 for the reason. Or as I mentioned earlier, I could see potentially part A being worth 3 points and part B only being worth 1. and maybe one of these 2 points instead being given to considering the velocity equals 0, right? There's lots of ways, in other words, that College Board could choose to structure their rubric. And so you want to make sure, as I've said before in other videos, that you don't leave anything blank. You put down anything you can think of related to the problem, because you don't know what kind of partial credit they're going to give you. We have no idea. They don't release the rubrics ahead of time, so you can't prepare yourself for that. So you want to put down anything you can think of. Even if you were reading part A and going, I don't know, well, put down that maybe you're trying to find where velocity equals 0, and maybe you write down the definition that the particle moves right when velocity is positive. Because maybe you snag a point that way, right? Put anything you can think of down related to the problem. Okay? Find the average acceleration of the particle on the time interval 0 to 4. So in the rubric that I released, I did this one 2 different ways, because I know, especially for those who maybe first learned average acceleration in physics, you might have used your change in velocity over change in time, or maybe even those of you who are just looking at your notes packet for average acceleration. This, by the way, was at the very top of the first page of your notes packet. So if you did v of 4 minus v of 0 over 4 minus 0, I did show the work for that. And if there's a question on that, send me an email. But I'm going to walk through this the way that I typically do average, which is kind of founded more in our Unit 4 idea, which is average is 1 over b minus a times the integral from a to b of whatever they ask you for the average of. So in this case, they're asking us for the average acceleration. Well, I don't have acceleration, I have velocity. And so you have one of 2 options. One, you can figure out what acceleration is, and I did do that actually in the rubric, so you could see what that looks like as well, but I wanted to walk through this one kind of third way. So again, you've seen 2 modeled in the rubric, 1 modeled here on the video. Hopefully I've caught your way through one of those. And again, if there's a question, let me know. But rather than actually find the acceleration, I'm just going to call it acceleration. I'm going to say, okay, what's the integral of acceleration? Well, the integral of acceleration is velocity. And then plugging in the upper, we have v of 4 minus plugging in the lower. And then v of 4 is 3 times 4 squared minus 8 times 4 plus 4 minus v of 0, which is 3 times 0 squared minus 8 times 0 plus 4. And then don't simplify. You don't have to. I did simplify in the rubric. It was 4. Let me actually double check this real quick. 4 minus 4 would be 4. 16, 48 minus 32 is 16 times 1/4 is 4, yeah. And this unfortunately was only 1 point, so even more of a reason to not simplify. If this had been your AP question, you don't need to, right? Okay, D, find A of 1, the acceleration of the particle at time t equals 1. Okay, so let's go ahead and find A of t now, if you haven't already. If you already found A of t in part C, you wouldn't have to find it again. But I didn't, so I'm going to go ahead and find A of t. A of t, remember, is the derivative of velocity. And my velocity is this 3t squared function, so my acceleration will be 6t minus 8. And so A of 1 is 6 times 1 minus 8, which again you don't have to simplify, but if you choose to, you get negative 2. Okay, this one was worth 2 points. 1 point came from your derivative. Oh, I'm sorry. I'm looking at the wrong one. This one was only worth 1 point for your answer, negative 2. Okay. I could, though, again, kind of talking about other places that they see points, I could see this one being a 2.1 potentially. Again, just depends on what College Board decides, but 1 point for finding A of t, 1 point for finding A of 1. Okay, sorry, the next one's the one that's worth 2 points. Is the speed of the particle increasing or decreasing at t equals 1? and give a reason for your answer. Okay, so this is on the back page of the first page of your particle motion packet. Speed increases when velocity and acceleration are the same, and decreases when velocity and acceleration are different. Right, and so at t equals 1, that's what we're looking to find, right? So we're going to go ahead and first find, okay, what's v of 1? Well, v of 1 is 3 times 1 squared minus 8 times 1 plus 4, which is 3 minus 8 plus 4, which is negative 1. And my a of 1 I found up above was negative 2. And so because both v of 1 and a of 1 are negative, my speed is increasing. Okay, and then like I said, this one was worth 2 points. 1 point came from considering v of 1 and a of 1, recognizing that they both impact whether speed increases or decreases, and 1 for your answer with reason. Okay, part F, find the position function x of t for the particle. Okay. So we're going to go ahead and find x of t here. Okay, so desired position formula is 7 plus the integral from 0 to t of my velocity. I'm going to call it v of a because I put t up here, so I don't want to call it v of t. And then this is where it kind of depends on directions here. I would say the ones that I have seen the most when it comes to College Board is they'll say find the position function x of t with an integral, right? Or using an integral or something like that. In which case, you're done, right? You have now found a function using an integral, and so you wouldn't go any further. I liked this one and decided to assign it because it didn't specify to use an integral, and so I liked that it gave us a chance to practice evaluating the integral. Really quickly here, you did get 1 point for using your initial condition. This was a 2-point problem. And I would say the second point of this is in my opinion, the most challenging part of it, which is doing that evaluation, okay? And so we're going to go ahead and take the integral of our velocity here. The integral of velocity, 3t squared minus 8t plus 4, is t cubed minus 4t squared plus 4t, if we integrated each of them, and that would have been your second point. Which, like I said, I wouldn't say that has been a common instruction on the AP test, but I do like I said, that it pushes us a little bit to kind of navigate something that maybe is unusual. Like I've said several times, you are going to have that happen on the AP test. College Board always constructs it so that we're kind of stretching, or they're stretching the limits of the student's testing to see, are you persevering, and kind of where is that upper boundary. You don't have to get 100%. You don't have to get it all right to be able to still get a 3, 4, even a 5. You could not finish a part and still get a 5 potentially. So make sure you don't give up. And so I like I said, I like this one because it threw that kind of a little bit more uncomfortable bit in there with part F. Because like I said, you're going to see it. You can't let that throw you, okay? And it was only 1 point, so again, you can't sweat the small stuff. Okay, G. Using your position function that you found in part F, and so again, if you maybe you made an error, you got stuck, whatever the case may be. First of all, if you get stuck, keep going, right? Get an equation. G says use your equation in part F. So get an equation. Make sure you aren't just making one up. Found it in the problem somehow, but get a function and use your function to find x of 1 and x of 4, because if you use your function right or wrong, again, as long as you didn't oversimplify the problem, you can't just say position is x squared, right? Found it in the problem, get a function, use your function to find x of 1 and x of 4, you can still get the 2 points that are possible in this problem, even if your function is wrong, right? As long as you use your function correctly. And again, one more time, haven't oversimplified. And so again, if you're sitting there going, I don't know if I oversimplified, send me a message, send me a picture, I can check it for you. Okay, so I'm going to use my function here to find x of 1, which is 7 plus 1 cubed minus 4 times 1 squared plus 4 times 1. And I'm not going to simplify because I don't have to. I did in the rubric though. And then 4 cubed minus 4 times 4 squared plus 4 times 4. And again, I'm not going to simplify. X of 4, by the way, simplifies to 23 because these would cancel. 7 plus 16 is 23. And then this one simplifies to 8 because these two would cancel. 7 plus 1 is 8. Okay, 2 points, 1 each. Okay, and then your last 3 points here come out of part H, which we learned to evaluate an absolute value integral in Unit 4. And I had planned to review this in class, but then school closure happened. And so we did one, or at least I think we did one a couple of videos ago. I don't remember for sure where it was, and maybe this is the first one we've done. But again, this comes out of Unit 4, and I have extra practice already created that I can send your way. If you're wanting to knock out a couple more of these, let me know. But evaluating an absolute value integral, we have total distance, which is integral from A to B of the absolute value of velocity. Okay, which I'm going to go ahead and rewrite with my velocity function here. Okay, the first thing we have to do is split our integral at its zeros. Well, the nice thing is we've already found the zeros of this function. We found them up here in part A. The zeros of this function were 2/3 and 2. Well, 2/3 is not on that interval, but 2 is. And so we're going to go from 1 to 2, and then 2 the rest of the way to 4. So we're splitting this 1 to 4 up as 2 integrals. And then we need to figure out which one of these is the positive leg that we're just going to drop the absolute value bars on because they weren't doing us any good, and which one of these is the negative leg that we're going to change the signs of so that we can drop the absolute value bars but still keep the function positive. And you figure that out by testing a number on your interval. And you can test 1 or you could test 1.5, it doesn't matter. But when you plug either 1 or 1.5 or whatever into your velocity, you see that this function is a negative function at, for example, t equals 1. Well, and then it can't be negative, it's absolute value, so we have to change those signs. Negative 3t squared plus 8t minus 4. So that means I'm pretty sure this one's positive, but let me go ahead and still check that. So I'm going to plug in 4 or 3, which is also on that interval. Again, doesn't matter. When I plug that in there, I do get a positive, and so I can drop those absolute value bars without inhibition. Okay, and then you're integrating. Okay, we have negative t cubed plus 4t squared minus 4t. And then t cubed minus 4t squared plus 4t. Plugging in the upper minus plugging in the lower. So negative 8 plus 4 times 4, which is 16. Minus 4 times 2, which is 8. And maybe you don't even simplify that. Maybe you do negative 2 cubed plus 4 times 2 squared minus 4 times 2. You don't even have to simplify to that point, right? Plugging the 1, negative 1 plus 4 minus 4. Plugging in the 4, 64 minus 64 plus 16. Minus plugging in the 2, 8 minus 16 plus 8. Okay? And then leave it alone. You don't have to simplify. If you do simplify, this simplifies to 17. Like I said, this one was worth 3 points. 1 point was for identifying what total distance was. So writing that down, knowing how to evaluate total distance. 1 point came from your integrals, splitting at 2, knowing which one was negative and positive, and then integrating. And then 1 point came from your answer. Okay? Okay, second one, we have an FF prime F double prime graph. So I'm looking at a graph of F here. Consists of 3 line segments and a quarter circle. So again, let me go ahead and shade in that quarter circle like I did in the other video. This quarter circle, thankfully, is face down, so I'll just be able to do 1/4 pi r squared and I'll have to do a subtraction. Radius of 2 shown below. G of x is the integral from 1 to x of f of t dt. And so again, I'm going to take a moment, take the derivative, plug in the upper, times the derivative of the upper, minus plug in the lower, times the derivative of the lower, which simplifies to just f of x, in case I need that at some point. Okay? Okay, first up, find the values of g of -4, g of 1, g of 3, and g of 4. Okay? So -4 is the integral from 1 to -4 of our f. G of 1 is the integral from 1 to 1 of f of t dt, which is 0. G of 3 is the integral from 1 to 3 of f of t dt. And g of 4 is the integral from 1 to 4 of f of t dt. Okay? This one's upside down, so I'm going to go ahead and fix that. Okay, and so then we have negative a bunch of areas from -4 to 1. So starting at -1 or -4 here, we have a triangle, 1/2 base of 2, height of 4. A quarter circle, so 1/4 pi my r, which is 2 squared. And this triangle right here, 1/2 base of 1, height of 2. And I don't have to simplify. If I do simplify, this simplifies to 4 plus 1, which is 5. So 5 plus pi minus, it would be -5 minus pi, if you were to simplify. Okay. G of 3, integral from 1 to 3. So starting at 1 here to 3 is just this triangle below the x-axis. So it's negative because it's below the x-axis. 1/2 base of 2, height of 2, which again you don't have to simplify, so you can leave it there or simplify it to -2, your choice. And then 1 to 4 is that same triangle with this additional little piece here from 3 to 4, which is 1/2 base of 1, height of 2, which again you can leave alone or simplify to -1, whichever one you prefer. This one was worth 4 points, 1 each. Okay. Part B, on the intervals -4 to 4, what value does g of x have a relative maxima or relative minima? Give reasons for your answer. Woohoo! This is what I had kind of prepared for up above here already. Which is to find a relative maxima or relative minima, we do need a first derivative of g here. All right, well, the first derivative of g is f of x. Okay, and so then where does your maxima occur? Well, it occurs when your first derivative changes from positive to negative, which is where? Okay, well, our first derivative here changes from positive to negative at 1. And so g of x has a relative max at x equals 1 because g prime changes from positive to negative. At x equals 1. Okay. And then what about relative minimum? Okay, well, relative minimum occurs when that first derivative changes from negative to positive, which is here at x equals 3. Okay. This one is worth 2 points. Nope, 3 points. I'm sorry, 3 points. 1 was for identifying that G prime equals F. 1 was for your relative maximum with reason. And 1 was for your relative minimum with reason. Okay. Okay, part C, on the interval -4 to 4, what are the absolute maximum and absolute minimum values of g of x? Show the work that supports your answer. So how do we find absolute maximums and absolute minimums again? Okay, well, it's 3.1. We take our first derivative, and we set it equal to 0. Okay, so where does f of x here equal 0? It equals 0 at -2, 1, and 3. And then for the record, we're now going to be testing by taking these numbers and our endpoints, which are -4 to 4, and we're going to be plugging them into our original function g. However, you don't actually have to test -2. -2 is neither a relative max nor a relative min, and so it will therefore be neither an absolute max nor an absolute min. So you actually don't have to test x equals -2, although I am going to for those who did. So our endpoints, -4 and 4, and our zeros, -2, 1, and 3. And we've actually found most of these already. We found them in part A. If you made a mistake in part A, and so got the wrong value for, say, g of 3, and you used g of 3's value down here again, you would not lose the point twice, right? So what I mean by that is this. G of 3 is -2, which we're going to find out in a bit here is neither the absolute max nor the absolute min. The absolute maximum value happens to actually be 0. But say you found g of 3 and you got 5. Well, then 5 would look like the absolute maximum. It would look like it was the biggest number. And so if you identified that value as your absolute maximum value, you wouldn't lose the point again. You already lost that point up here in part A when you said g of 3 equals 5. As long as you didn't just make that number up, that would be called oversimplifying. But if you founded that number in the problem and just made a simplification error or something like that, and used that number and it got you a wrong answer down here, you wouldn't lose the answer twice. Okay? And again, if there's questions on that, send them my way. And g of 1 we found was 0. G of 4 we found was -1. G of -4 we found was -5 minus pi. And if you wanted to, you could take a moment here really quickly and solve -2, which would be the integral from 1 to -2, which is upside down. Which is this next to -2 to 1 is the quarter circle and the triangle, -2 to 1. So the quarter circle and the triangle, which is just 1 plus pi, right? And then negative that, so it'd be -1 minus pi. If you'd like. Okay, so your absolute maximum value and absolute minimum are, let's start with that minimum. So where do you see the smallest value? Okay, well, your smallest value is right here, -5 minus pi. Okay, and what about absolute max? Okay, well, our biggest value is here, 0. All the others are negative. Okay. Okay, this one was worth 3 points. 1 for identifying 1 and 3 as candidates, and then 1 for your absolute min, 1 for your absolute max. Okay, D, where does G have points of inflection? Okay. Well, remember G prime is the same thing as F, so how do I see G's points of inflection on its first derivative graph? Well, points of inflection on a first derivative graph are where the first derivative changes from increasing to decreasing or decreasing to increasing, which are here at -2, 0, and 2. Okay? And then I always write my reasons separate for kind of each set of points. There are other ways of writing your reasons, so if you wrote it differently and aren't comfortable assessing if your reason was good enough, send it to me. I'm more than happy to check it. Increasing to increasing at those points. And at x equals 0, because G prime which equals f of x changes from increasing to decreasing. Time management strategy. If you are sitting there feeling like you're a little bit short on time, maybe jot down a rough explanation, move on, grab some of those other points, and then come back and add to your explanations. You definitely shouldn't be finishing your FRQs early. If you find yourself finishing your FRQs early, go back to your explanation and reasons, read them again, make sure you've removed any its or those, like make sure your explanations are very clear. Exactly what are you referencing, plug any hole that you can see. Make sure you've very clearly written out your work. So that's what you should be doing with any extra time you find yourself having. Okay, this one is worth 3 points. One was for the -2 and 2, one was for the 0, and then one was for your reasoning, which again, this is not the only reason. So if you found another reason, feel free to run it by me. I'm more than happy to check it for you. This is my reason, okay? And then part E, calculate the value of the integral from 1 to 4 of the absolute value of f. And so we're going from 1 to 4 here, which is these two triangles. However, it is absolute value. So this triangle from 1 to 3 here, which would normally be below the x-axis, would normally be negative. It's now going to be positive because of the absolute value bars flipped up above the x-axis. And so as we do this one's real quick. That triangle below the x-axis, 1/2 base of 2, height of 2. Normally negative, but now positive. And then the little triangle from 3 to 4, 1/2 base of 1, height of 2. Which again, you don't have to simplify, but you can. It simplifies to 3. This one was worth 2 points. 1 for considering positive values for the integral, and 1 for your answer. Okay? Okay, last one. We have a graph of f prime and a table with values of g prime and g double prime. Interval 0 to 6, it is known that f of 0 equals -2, so I'm going to go ahead and write that down. Desired position formula. Graph of f prime consisting of 2 line segments is shown along with g prime and g double prime in the table. Okay. A, at what value of x does f of x have a relative maximum? Okay, well I don't have f of x, I have f prime. So how do I see where f has a relative maximum on an f prime graph? Okay, well, f has a relative maximum when f prime changes from positive to negative, which is here at x equals 2. And then give a reason. So f of x has a relative maximum at x equals 2 because f prime of x changes from positive to negative. This one is going to be worth 2 points. 1 for your answer, 1 for your reason. Okay? B, what value of x does g of x have a relative minimum? Give a reason. So in my opinion, B here is actually one of the more challenging parts of this particular problem. And so same thing as what will happen on your AP test, because again, one more time, you need to expect challenging parts. It's going to happen. You're going to see parts that are weird or out there because College Board is stretching you, right? So if you were on your AP test and you hit part B and you read it and you're like, I don't know, we'll skip it, move on, go on to part C, go on to part D, grab your other points, and come back to part B when you're ready. I wouldn't recommend leaving it blank. Jot down anything you can think of related to the problem. Maybe it's the definition of a relative minimum. Because again, you don't know what the rubric's going to look like. You don't know what the partial credit therefore will be. And you want to try to grab some of those points. Okay? But walking through part B here, which was worth 2 points, at what value of x does g of x have a relative minimum? Give a reason. G of x, well, first of all, where does a relative minimum occur? Okay, well, a relative minimum occurs when the first derivative equals 0, which is here. I should highlight this. Here and here. And then it's where your first derivative changes from negative to positive. And unfortunately, that's where we fall through a little bit here, is because we don't see our first derivative changing from negative to positive, right? I'm negative and then 0 and then 0 again and then negative. And so that definition on its own isn't enough, but I'm pretty sure that it's going to be either 2 or 4 for my answer. Okay, so what else do we know about a relative minimum? And this is where it gets, like I said, in my opinion, this is one of the more challenging parts of the problem. What else do we know about a relative minimum? And then let me give you a hint. What do we know about the concavity when we have a relative minimum? Okay, well, we don't know it's concave down, but I would say a lot of concave up. We don't know that it's concave up, but I'd say a lot of relative minimums are when the function is concave up. Again, obviously, if the relative minimum was a cusp, we wouldn't see any concavity, but anyway, we're going to operate with this concave up idea because that's something else I know about a relative minimum. We'll look at my second derivative then. So what is it? First of all, what is it? Second derivative when we're concave up. Second derivative is positive. Look at my second derivative at those 2 points that we identified as possible relative minimums. My second derivative is positive here. It's not here, right? This second derivative is negative, meaning that I'd be concave down. Okay, that's not a relative minimum, that's a relative maximum, right? And so g of x has a relative minimum at x equals 2 because g prime of x equals 0 and g double prime, g prime of 2 equals 0. And g double prime of 2 is positive. Okay? So those are 2 points, 1 for your answer, 1 for your reason. Okay, part C, write an expression for f of x that includes an integral. Okay, this is that set of directions I was referencing earlier. This one is definitely much more common, which is write an expression that includes an integral. So we would have -2 plus 0 to x here of our derivative, which was my f prime graph, or velocity if we had velocity, but in this case we just have f prime. So we're using this desired position formula here. Okay? And then use that expression to find f of 2 and f of 5. Okay, well, f of 2 then is -2 plus the integral from 0 to 2. And f of 5 is -2 plus the integral from 0 to 5. Okay? Well, 0 to 2 on my f prime graph is this triangle here, 1/2, base of 2, height of 2, which is -2 plus 2, which is 0. And then 0 to 5 is that same triangle plus one more one, this triangle down below the x-axis, which is negative because it's below the x-axis, 1/2 base of 3, height of 1, which is 0, minus or plus -3/2, which is -3/2. Okay, this one was worth 3 points, 1 for each thing we had to find: f of x, f of 2, and f of 5. Okay. Part D, find the absolute minimum value of f of x on the interval 0 to 6. Show the analysis that leads to your work. How do we find absolute minimums again? Okay, well, we take our derivative and we set it equal to 0. So where does f prime equal 0? Okay, f prime equals 0 at 2 and 5. And then we take those values and our endpoints, which in this case 0 and 6, and we plug them into our original function, which is f. And then again, just for the record, you don't actually have to test all of these values. 2 would never be an absolute minimum, because 2 is a relative maximum. It's where f prime changes from positive to negative, right? We identified that in part A. It's a relative maximum. So it can't be the absolute minimum if it's a relative maximum. Okay, so you actually don't have to evaluate 2. I will, though. We actually already did. We did 2 and 5 up in part C. 2 we got 0, 5 we got -3/2. Again, one more time, a reminder from the previous video that or actually just from the previous problem, that if you had mistakenly identified, maybe you'd gotten f of 2 equals 4, and so you put 4 down here, you wouldn't get double docked, right? So make sure you're not doing that as you correct your own homework, as long as you haven't oversimplified the problem. And so again, feel free to send it my way if you're not sure. Okay? F of 0 then is our -2. We were given that up here. Or you could plug 0 into this expression if you wanted. And then f of 6 is -2 plus the integral from 0 to 6 of f prime, which is -2 plus, now we're going all the way, so the same thing as f of 5, but including this little triangle back here, base of 1, height of 1/2. So the first triangle above the x-axis, second triangle below, little itty-bitty triangle at the end. Which simplifies to -3/2 plus 1/4, which is wow. Okay, sorry. I didn't actually simplify this. I'll add that to the rubric. -3/2 is -6/4. There we go. -6/4 plus 1/4 is -5/4. Again, I didn't, just because they were asking for a relative minimum, and so for me, when I was doing this, I was like -3/2, we're adding a positive to it. This value is already going to be bigger than -3/2, and so I didn't bother simplifying, but you could if you wanted to. Or maybe turn it into decimals if you prefer, -1.5 plus 0.25 and get -1.25 if you wanted to. You don't feel bad about using decimals if you're more comfortable with that. Okay, so our absolute minimum value is right here, f of 0 equals -2. Okay, this one was worth 3 points. 1 for considering f of 5, 1 for considering f of 0, the x equals 0, and 1 for your answer. Okay, 2 more here. On the interval 0 to 6, is there a value of c such that g prime of c equals -2? So explain your reasoning. If not, state that there is no such value. So this one here is MVT, right? MVT is how we guarantee that a derivative exists. So the first thing we need to be able to say is that we're differentiable and therefore continuous. 3.2, by the way, is where this is. Are we differentiable and therefore continuous for G? Yeah, we're looking at G here. Okay. Well, yes, we can say that because they tell us in the first sentence, G of x is differentiable. Okay? And so then what else do we need to find? Well, we need to find a place where my f of b minus f of a over b minus a equals the derivative I'm trying to guarantee. And I made the comment a number of times now, but I'm going to say it again. I myself, when I do this, always start with the endpoints. I start with 6, and so g of 6 minus g of 0 over 6 minus 0. However, when you do that, g of 6 minus g of 0, you get -6 over 6 minus 0, which is 6. You get -1, which is not -2. Okay? And so then we would test other values. So 0 and 6 didn't work. Well, maybe we try 2 and 6, or 0 and 4, or 2 and 4, right? Like 4 and 6. You test values until you figure out where that -2 exists, which for us is actually going to exist at 0 and 2. G of 2 is 0. G of 0 is 4, which is -4 over 2, or -2. And so yes, because G is differentiable, and therefore continuous, and G of 2 minus G of 0 over 2 minus 0 equals -2. Okay? 2 points. 1 for finding that G of 2 minus G of 0 over 2 minus 0, and 1 for your reason with answer, which did have to include the idea that you were differentiable and continuous. Okay, last 3 points here come from part A. We have evaluating our limit. Okay, and so if I plug in my upper here, limit as x approaches 2 of f of x. If I plug 2 into f of x, what I get, right, is 0. I found that up here. When I plug f of 2 into f of x, f of 2, I get 0. Okay? And when I plug 2 into g of x, g of x2, I also get 0. Well, I can't get 0 over 0, so I therefore have to do something. Out of Unit 1, we looked at like multiplying by a conjugate or factoring or something like that. But the very last lesson we learned before break was something called L'Hopital's. So therefore, using L'Hopital's rule, I can take the derivative, the limit as x approaches 2 of f of x over g of x is equal to the limit as x approaches 2 Derivative of f is f prime over g prime. Okay, and so I'm going to go ahead and plug in 2 there. Okay, well, f prime of 2, this is f prime. I'm looking at f prime. What's f prime of 2? F prime of 2 is 0. I'm plugging into my denominator. G prime, what's the g prime of 2? G prime of 2 is also 0. Still have 0, 0, therefore cannot give an answer. I'm going to use L'Hopital's again. Limit as x approaches 2 of f prime of x over g prime of x, taking the derivative. So the limit as x approaches 2 of f double prime of x over g double prime of x. And so now when I plug in, the limit as x approaches 2 of f double prime of x equals, okay, well, f double prime is the derivative of f prime, or the slope of f prime. F double prime is down 1 over 1, down 1 over 1, down 1 over 1. So negative 1. So already looking more promising. What about g double prime at 2? G double prime at 2 is 2. Woohoo! So therefore, the limit as x approaches 2 of f of x over g of x, which equals f prime of x over g prime of x, which equals the second derivative. F double prime was negative 1, g double prime was 2. It's negative 1/2. Okay? 3 points for this one. And by the way, this is not the only way to show your work. This is one way. In the rubric, I actually did it a slightly different way, so you have options with how you prefer to kind of notate it. And again, even my 2 ways are not the only way, so if you wrote it a different way and you're just kind of wanting to double check things, send it my way. I'm more than happy to do that. But first up, your first point comes from testing, plugging in, doing your substitutions. 1 point came from using your L'Hopital's rule, and 1 point came from your answer. Okay? Okay, those are your 25 minutes. Again, if there are questions on any of those or the 2 15 minutes from FRQ 5, send them my way. There you go.